Okay, so let's define. Okay, so M is a bounded measurable function. Okay, in Rn, then we define the operator Tm fx is equal to M f transform and the transform x. Okay, then this is for f in L1 in Rn intersection L2 in Rn. Okay, so another definition, we can say that M is an LP multiplier F. The norm of Tm F P is less than or equal than a constant Cp, norm of F P, and this is for all F L2 R n this intersection with LP Rn. Okay, so a remark, DCP. Okay, so let's say the smallest CP let's say CP star is the norm of the operator norm of Tm in LP. Okay, and another remark that if M is an LP multiplier, then M is this is for 1, P between 1 and infinity, then M is a LP prime multiplier with well, 1 over P plus 1 over P prime is equal to 1. Okay, and Cp prime is equal to Cp. Okay, so let's announce the theorem. This of Michelin and Hermann. Okay, so let M in CKRN but not the 0, with K is a positive integer, K is greater than N over 2, if for alpha less than or equal than K over 2, we have that the supreme are positive, R minus N to alpha absolute value R less than C 2R. Okay, so delta alpha C M C squared D C is equal to, well, let's say A alpha, and this is less than infinity. Okay, so if we can find this bound, and recall that here is the m that we've been using in the multipliers. So then m is an LP multiplier, okay, for any p in 1 infinity, and moreover Tm is of weak type 1 1. Okay, so um, this is to say that lambda times the measure of the set of the x in Rn, such that Tm of x is greater than lambda. This measure multiplied by lambda is less than or equal than a constant um, multiplied by the norm f1 in this case. Okay, of course this is for all f in L1 or n. Okay, so some properties of the multiplier. Well, first, that Tm1 of Tm2 will be equal to Tm1 multiplied by M2. Okay, and the second one, Tm1 so on will be equal to Tm1 measurement. Okay, well, you can easily say both of them, just taking in consideration the definition of Tm of f, that is m multiplied by m of f transform anti-transform. And so, for example, if you want to make Tm1 Tm2f, okay, then you will have just to apply the definition, and that will be m1 T of m2f, okay, but all these has to be anti-transform, and so then you will have a m1 multiplied by m2 af transform. Okay, so then with some steps in between, you will have m1 m2 um, multiplied by af transform anti-transform. Okay, and we will get back to what we wanted. Something similar can be done with 2, so these are easy properties to prove.